protocol stack, Wi-Fi is only defined by the physical layer MAC layer. That's why as per my Electronics and Communication Society, we do not directly call it as Wi-Fi. It's a complete protocol stack. We say it as Wi-Fi. So when coming to this MAC layer of specification, we call it as IEEE 802.11. Right? So generally this IEEE is a standard layer of standards. Mainly this is 802 is related to the communication standardized technology, where 802 has different type of specific technologies. Like for example, uh, 802.3, this is actually Ethernet. No one has Ethernet, but it is actually 802.3. When I say 802.3, when I say Ethernet, what makes the difference is 802.3 is a standard IEEE, and it only defines the physical MAC layer. When I say Ethernet, then Ethernet is complete protocol stack. So what are the different standards I told earlier? All these standards are connected technologies, but they only define the physical layer. Let me show some interesting things. One is 802.3 all is Ethernet, and the other one is 802.15 or 802.11, which is actually wireless LAN, basically Wi-Fi, and 802.15, which is Bluetooth. But if I call it as Bluetooth, I better than call it as 802.15. If I was speaking only in Bluetooth, then I call it as 802.15. So this is also completely Wi-Fi. So what is Wi-Fi and how the devices are connected? Then Wi-Fi are connected like broadly two ways that we can Wi-Fi. Where we connect the devices one is and you are Wi-Fi hotspot, there is a hotspot and access point will be there. And it will broadcast the packets will be connected based on the SSID connection. Yes. That is one way. The other is how can you transfer your photos to the other phone without internet? Every mobile has Bluetooth is a different technology as I said. Bluetooth is 802.3 and this is between 802.11. What is the other way of communication using a hotspot? Generally, people do not say anything. It uses a local Wi-Fi. And it is shifted around. It's analog mode. Is there any access point or any central device is required or any router is required to transfer it to the other phone? Not what it. So basically, there are two ways where you can use Wi-Fi. One is a hotspot, and all the devices will be connected. And where all the devices can be without any single coordinate. It's a very basic network topology that any wireless LAN. Okay. So, as I said, Wi-Fi, which is basically generally mobile is connected to the other Wi-Fi. Everything is via wireless. But if you see here, when I call it as 802.11, it only specifies the first device, the physical layer and the MAC layer. So this is a mobile device, and this is another mobile device. Where these two are connected by a router or a switch by a whatever it may be. But when I see all these things are wireless, and what basically 802.11 do is, it only specifies. Please remember this code specifies. We will come to it. So it only specifies the physical layer and MAC. So what is physical layer and what is MAC layer? What is physical layer and what is MAC layer? Let us just give a very generic example, then move to the technicality. If I also explain in infrastructure to another person, what is actually required? First, I should know the access of the other person. If the other person is not directly accessible to me, then I should do the third party, then the third party will be the destination. So here, what is this layering? Every layer some roles and responsibilities. You are not in that. These are different. So to better understand, if you just check with your mobile, how many connectivity technologies are there in your mobile? If you consider a mobile device, a cell phone, how many technologies are there that enable communicate in your mobile? Whether your mobile can communicate or not. How many ways? How many technologies can we communicate? One is through the mobile network, basically the networking or 5G. Then you can communicate through Bluetooth. You can communicate through Wi-Fi. Even you can communicate through NFC, like mobile, right? Every mobile device will have different technology hardware, and every hardware has a physical layer, right? And what the physical layer mainly do is, as we are from communication background, this physical layer is solo responsible for the actual modulation and coding scheme. Like if I want to send some information, we know that communication system works. So analog or digital information we initially encoded, then channel encoded, the source encoded, the channel encoded, then possible channel. So where all this modulation and coding is basically done by the physical layer. And what that layer does, if I am speaking to you, what is actually the chance between us? The free space. And on the electric trees, there is a source and there are multiple destinations. How can you say that the entire channel among the use? This is one of the important roles and responsibilities of the mind. Similarly, the network transport and the physical layer also have different roles and responsibilities. But let me stick to these two layers because it not to find only specified use case. As I said, mainly the physical layers of what modulation you want to use to communicate. So what are the basic modulation that you use for Wi-Fi? When you share your photos to other person using a hotspot. So what are the modulation you use? What is the modulation scheme? Please. Basically, OFDM currently used, right? But in the future, maybe ODSS will also be part of the Wi-Fi. So, similarly, coming to the MAC layer, as I said, some of the main roles and responsibilities on the MAC layer. One of the important is access mechanism. What is access mechanism? If let's say, a channel, how to share among all the users? That is what I really call as access mechanism. I'm not going into the details of these two. So now, so quickly, what is the physical layer and what are the different modulation use schemes? Initially, there are different type of standards. There is some standard in order to point them. Have you ever seen something like 4.11, A, B, G, F, AC? What is the current pipe that is being publicly used? What is the version of Wi-Fi that we are now using? The latest Wi-Fi that is used. Wi-Fi? Wi-Fi 6. Right? Before was Wi-Fi 5 and Wi-Fi 10. So Wi-Fi 6 is based on Wi-Fi 8.2.11 AES. The previous one was 5 Wi-Fi 10, which is I3.2.11 AC. And then we now access. But now what will be coming in future is VNs. So I3.2.11 which is mainly Wi-Fi 8. Of course, Wi-Fi 7 is not almost easy. But maybe going into the doing the especially shifting to Wi-Fi 8 because 7 and 8 are the same features. So coming to this every standard of the layer is of different types of modulated techniques. And quickly cover this. One type of technology that we use is infrared. Basically, infrared with PPM or PWM. And even the physical layer that initial Wi-Fi, because this sensors is different from the spectrum. Also, EES sensors that is different from the spectrum. These two are the modulated techniques that were initially used because what is DSSS means? If I want to use every bit will need 120 some chips. 180 transfer. what is the frequency of the meetings, will be calculated into transmitted in different frequency, where the frequencies are generated manually. That is the click available. And of course, current Wi-Fi, as I already said, is mainly based on AMP, orthogonal frequency multiplexing. So this is what the brief things of the physical layer. Only the physical layer covers. Physical layer covers only the modulation frequencies. Few of them are either it will be infrared, which is based on PPM, or it can be any one of the modulation like DSS or HSS or whatever. Now coming to the magnitude, the main part of today's talk. As I already said, magnitude means one of the input mechanisms. It shapes the channel. How the channel will be shaped among multiple chips. That's what one of the important responsibilities of this magnitude. And I could be able to point level. This channel axis is being bound by a mechanism called as DCF. DCF stands for distributed coordination function. Right? So basically, this DCF employs two different mechanisms. One is CSMAC, which is known as so maybe the Wi-Fi magnitude, the channel is shaded by known as DCF. This is mainly contains two different types of mechanisms. One is DCF axis on CSMAC and binary exponential type of algorithm. I'll just use this simple example. So to illustrate that, let me consider that there is a source and there is a destination. So that is to communicate the destination. Just get a resistant data packet and which you can get all its back. Or there is one more thing. So can send an RPS. That means it's custom set. And the destination is a serious packet. Once this exchange happens, then the phone can send a data followed by encodation. This is what two ways where we can communicate the link. Right? But how it can be realistically implemented? And what are the major problems? There is one important problem called as redundancy. What is redundancy? For example, let us consider that this is a device A, E, and C. If A and B are in communication, that means that they can listen to each other. And if B and C are also in communication. Now, if you check that, A and B are in communication and B is in communication. But E and A and C are not in communication. Then what will happen? If A communicates back to B, at the same time, if C also communicates back to B, then they will be colliding. So obviously, it was some interference. So this is what I said earlier. Similarly, exposure. So these are the two important problems that every Wi-Fi network experiences. To avoid that, there is any RCS mechanism. So what is this RCS mechanism? Consider that there are two nodes ABC. In this example, A and C wants to communicate with B. But if A and B, like for example, I'm there and there is another person there, and in between there is one more person. Me and the last person wants to communicate with every person. If we both speak at the time, then whether there is no understanding. We are facing here. What can we do? But here, that is. So what this DCF says? A and C, those that are computing with C, they will wait or they will sense the chart. They will sense the chart. For some mechanics called as DIF. After sensing the chart, what they do is they will initialize a random, like the last one has chosen a random value 7, and I have chosen a random value 5. And what we do is we will be decrementing it towards the C. Whoever decrements first, they will win the chart and they will lead into the other. Similarly, this A and C, they have started here. Immediately they didn't win any data. So what they did is they have sent the channel for EIFS. Then A has chosen a random value of 3, C has chosen a random value of, and both A and B starts decrementing to 0, and A will decrement to 0 as per this example. So as A is decremented first, it immediately sends an RPS packet to B, and B sends the APS packet, and A sends the data to B, and B will acknowledge. So a perfect communication has happened between A and B. Meanwhile, C has not communication because C has known that A has already won the channel. So it has simply separated by power. Okay. So this is how again an example of this. So again it has a channel for the time called as EIFS. But now as A has completed one transmission perfectly, A has chosen a value of 5, and C's previous value is 5. So both the values are 5. Once they start towards 0, both the decrements at the same instant of 5. Now, if they start sending the RPS packet, they will end up with collision. Again, this will be happening again and again. This is how the actual Wi-Fi devices communicate. Okay. So, any doubts with this? Because this slide plays a very important role for the upcoming slides. If you have any doubt with this, you can ask me. Mainly, what I'm saying is, whatever I have covered so far is basically IEEE 802.11 is a standard that describes the Wi-Fi. And especially this standard mainly describes the physical layer and MAC layer. On the physical layer, there are different modulation and coding schemes for different substandards like that. Different substandards like A, B, G, and AC, and so on. Coming to the MAC layer, there is only one mechanism that can share the channel, that is DCF. DCF is mainly based on CSMA and binary exponential backup. These two mechanisms are being perfectly utilized to share the entire media among any number of users. Okay. And this picture clearly illustrates how it is being shared among ABs. Any doubts, please? Any doubts? So next, what we do is let me just whatever the mechanism that I have explained, let me just try to convert that into a mathematical. Because this lecture is more towards the mathematics, modeling, and machine learning. We should know some little mathematics related to this. So here, I said that two mechanisms. One is CSMA, carrier cells multiple axis, it's collision avoidance. Other one is binary exponential type of. So what is BEB? You can look at here. Initially, every user will choose a random value. So that random value is something called impact of counter or continuity. Anything you can recall. So generally, every device will choose the initial contention window, that is CWB. So whenever a collision occurs, if both devices contention window is same and they decrement to 0 at same instant of time, then a collision occurs. If a collision occurs, then it will be the backup counter will be double. Okay. So as the number of collisions is occurring every instant of time, this backup counter will be just going on increment. That means it will be just double. So, but once a device experiences a successful transmission, then it will be reset to the contention window. So this is what actually is called as binary exponential backup algorithm. Okay. So because I'm not giving too much illustrative example, if you have any doubts, you can interrupt me at any point of time. So this incrementation, we have a limit that is called as maximum contention window. If number of collisions increases and the contention window reaches the maximum value, so it will not go beyond. It will be staying there, but once a successful transmission happens, it will be reset to the minimum contention window. So this is what actually binary exponential backup is. Okay. So you so here I would like to illustrate two terms. One is so this range is called as backup counter, and this backup counter is being doubled every time. You can see here it is being doubled every time. So once it is being doubled, that whenever it is doubled, I call it as an incrementation in the stage, and that stage is called as backup stage. So this is the 0th backup stage, and this is the first backup stage, second, third, and so on. In every backup stage, the contention counter or the backup counter will be doubled. So two terms are there. Please try to remember. So there is a backup counter and there is a backup stage. So with these two terms, let me illustrate mathematically. So here, I illustrate this mechanism using mathematics one technique called as Markov chain modeling. Here, this Markov chain model is basically a state diagram. So every state composes of two terms. One is backup counter and backup stage. So that is backup counter is denoted by B of T, and backup stage is denoted as S of T. Okay. So you can look at this. For example, if my backup counter is K plus 1, and if I move to a state where my backup counter is K, so from K plus 1 to K, what does it mean? Is it decrementation or increment? It's decrement, right? So, and I'm at the same backup stage, that is, I'm at the ith backup stage, but my counter is being decremented. So this is actually one of the possibility that I said before. So initially there are three devices. A device chooses a backup counter, for example 5, 5, 4, 3, 2, 1. To decrement this, what is the probability? It's just the probability is 1. So here this transition is being defined by this conditional probability. P of I comma k given P of I of I comma k plus 1. What does it mean is initially I'm at k plus 1 state at I backup stage, and I'm moving to a state called as k in the same backup stage. So what is the probability? The probability is. Similarly, there is one more transition probability. So for example, if I am at my initial counter value is 0, and I'm moving to a kth value, but I'm initially backup stage of I, and I move to the 0th backup. What does it mean? Is it means a successful transition. If you don't understand, at least try to remember this. It is more towards mathematics. But whatever the diagram that I've shown, the equivalent part, that means how that diagram, how that mechanism can be represented in mathematics. That's what I'm explaining. Why mathematical term means? Because every network, if it is properly modeled in terms of mathematics, you can analyze it and you can check whether any flaws are there, if there is any flaws, you can properly develop the protocol. That is what the main important thing in the mathematics is. So coming to the one more transition probability here. So I'm at the zero counter value and I'm at a back of stage I. If my counter value moves to k and I move to I plus 1 back of stage, that means it's a collision. If my back of stage increases, it's a collision. If the back of state is reset to 0, it is called as successful transmission. So the collision property is given by V by W. So combining all these things, let me show you. So this is what a combined diagram. Initially, a device will be at this stage. This is the zeros back of stage, 1 and so on, I minus 1, I up to m back of stages are there. Every back of stage has a range of counter values. So these counter values will be decremented. Once it decrements to 0, I have two options. Whether there is a successful transmission or there is a collision. If there is a successful transmission, I will be going upwards. And if there is a collision, I will be moving downwards. So this state transition diagram, whatever this diagram, this is mainly used to analyze the throughput of a network, which is very important because if I am watching a movie and if the Wi-Fi speed is not good, it's not possible, right? So throughput is a very important parameter. How we can evaluate the throughput is from this state diagram, you can evaluate something called as probability of transmission. So from this probability of transmission, you can define the throughput. I'm not going deep into the mathematics. So this is how you can define how this is how you can how you can formulate or how you can model the Wi-Fi network and you can mathematically evaluate the throughput. So let me just quickly ask you one question. Have you ever downloaded any movie over Wi-Fi? Huh? So no, please. Let's come from this heat for some time. So if you have downloaded any movie, so what will be the numbers that appears while you are downloading any movie or anything? Huh? So generally, we purchase this broadband connection. Generally, they will be selling at different rates. Maybe 10 Mbps connection, 30 Mbps connection. Yes or no, please? So if, for example, if I have my broadband is a 30 Mbps connection, then what may be the maximum rate I can download any movie or anything? What I'm basically asking is, what we download is called as a transfer rate. So what is given is a different speed. For example, if I'm given with a 64 Mbps, with what speed I will be able to download? Any idea? With what speed I am able to download? This 1 MB, that B is very small b or capital B? It's small b. So then how can it will be, what will be actually the transfer rate? Generally, if it's a capital B, how many bits do you have in a byte? Huh? 8 bits. So if it is generally everyone, no one will sell with capital B. It's not M capital B PS. It's small b PS, right? Generally, if I take at 64 or 32 Mbps speed, I will get the actual transfer rate by 8. 32 by 8. How is 32 by 8? It is 4 MB. That means I can download 1 MB. I mean, I can download 4 MB in 1 second. So to download a 400 MB movie, how much time is required? 400 seconds. That's it. But here there is a catch. How it is being downloaded is basically internally this mechanism is being used because it's basically a hotspot. Wi-Fi will be normally shared to me, shared to some other people. But as I am getting 4 Mbps capital MB, as I'm actually getting 4 MB means that means none of you should be using. Yes or no, please? If at least your friend also downloads the same movie, what will happen? I will get 2 Mbps the other will get. Similarly, if there are 10 people, if there are 10 people, what will be the data rate there? It's 400 kbps. 100 people, nothing will be downloaded. It's not of this. This is what generally happens with the Wi-Fi. That's why what is happening nowadays is the next Wi-Fi, not now. Even now we are at Wi-Fi 6, which is basically based on IEEE 802.11 AX. Even this do not have this feature. But this Wi-Fi 7 and 8 has a new feature called as, what is this? Multi-link operation. So what this multi-link operation do is, it enables simultaneous transmissions at different frequency bands. So what is different frequency bands? Let me just give you this topic. What is the frequency spectrum allocated to Wi-Fi? Okay, before that, what is ISL? You know that the entire electromagnetic spectrum so contains different frequency range, right? What is the range of the spectrum that we have? It starts at, what is the electromagnetic spectrum? Starts at radio waves, microwaves, infrared, visible, UV, X-rays, and gamma rays. If I'm correct. Okay. So in this entire electromagnetic spectrum, what is the spectrum that we are interested in for communications? Huh? Radio waves is the only spectrum because that is only very we can take it because the specific absorption rate is bearable. Or can you use X-rays for communication? We cannot because X-rays will penetrate into us. So the SCR for it is very high. We cannot use. Even we cannot use any other apart from radio waves. Even microwaves at low power, microwaves at low transmitting power is recommended, but at high transmitting power it's dangerous. So coming to this, when we have Wi-Fi in this entire radio wave stage, so what is the range of the spectrum for radio waves? Radio waves and the everything together. Millimeter wave and the radio wave, everything together. It is from approximately from 300 megahertz to 30 gigahertz. Let me consider this broad frequency spectrum. In this, as you said, the mobile devices, every mobile have one part for cellular communication, one part for Wi-Fi, one part for NFC, one part for Bluetooth. Where these entire technologies are operating there. For example, if I take Wi-Fi, at what part of the spectrum? What is the carrier actually I'm asking? What part of the spectrum the Wi-Fi is being used? Wi-Fi operates at which frequency? Anyone picks? 2.4 gigahertz. Is it only 2.4? Some of you, I think, in your mobile phone, there is an option to switch your carrier. Maybe some mobile phones has this. What is the other frequency? Yes? Fine. How many of your phones have that? How many of your phones have an option to switch your Wi-Fi from 2.4 gigahertz to 5 gigahertz? None of your mobile have. Hey, nowadays every mobile has it. Maybe you may have not chosen this. Oh, sorry. We are generally interested in camera, right? So you may have not chosen. Okay. So generally, this Wi-Fi has Wi-Fi can operate at 2.4 or 5, but not simultaneously. If it is connected to a network with 2.4, it only communicates in 2.4. Or if it is connected to a network with 5 GHz, it operates there. But this Wi-Fi 7 is not like this one. This Wi-Fi 7, which will be coming next, maybe hardly in this year or next year, Wi-Fi 7 and Wi-Fi 8. It has a multi-link operation where all the different technologies, because till now we don't have 6 GHz and 4, but 2.4 and 5 are there, but 6 will also be coming. Maybe I think iPhone 16 or all may have this in some parts of the countries. So if there are 3 different spectrums in your phone, these can be simultaneously used to transfer to the other device. That means you can, for example, if I want to download a movie now, which is actually 400 MB, I can download at 2.4 gigahertz as well as I can download it at 5 gigahertz. Even if 6 is supported, I can even download at 6. Obviously, what is the advantage that I get? A simultaneous data transfer is happening at 3 different frequencies rather than 1. This obviously reduces what? Reduces what? Latency. Latency means delay. So rather than it takes 400 seconds, now it takes 4 seconds to download a complete. And I have not changed that 64 Mbps. My connection is at 64 Mbps, but because of the MLO multi-link operation, I can download it at 4 seconds. But if there is a single link operation, I can download it 400 seconds. This is what a very new Mac feature that came to IEEE 2.11, especially the BN and BE and BN sequence. Okay. So what is multi-link? I'm not going to too much technical jargon. Okay, I'm just giving some simple points. So what is this? Is generally there are two types of the devices are categorized as two. Generally, they are called as MLDs. MLD stands for multi-link devices. So these MLDs, they are generally categorized as two types. One is access point MLDs and non-access point MLDs. Access point means the routers. You have the access points which are basically the routers. If multiple access points or a single access point with multiple links, these are grouped together and called as access point MLD. So what is non-access point MLD means a group of stations or stations with multiple links. It's a non-API. Basically, a mobile device is a non-access point MLD, and a virtual router which has this feature is called as a API. So here in MLO, one of the main things is there is one scheme or there is one procedure called as this MAC service access point, because you know that if I want to communicate to any person, I should know two addresses hardly. Of course, there are multiple addresses required, but at basic level, two addresses are required. One is MAC address, other one is IP address. Right? MAC address is the real hardware address. But when I have a Wi-Fi device with multiple links enabled, and if there are multiple stations like that, generally there is a group of MAC addresses. Right? It's not a single MAC address. So all these MAC addresses will be aggregated, and this MAC address will be coordinated by something called as MAC SA. So this is what a new feature that is being enabled in this multi-link operation. So basically what this MLO do is, this MLO enables, for example, certified it's not visible, but what is this is, this is a mobile station and this is an access point. Either it can communicate with a single link or it can communicate with multiple links. When it is communicating with multiple links, one link can be used to transmit, other link can be used for a simultaneous transmission can happen. So there is a lot of features with this multi-link operation. And one important feature in the coming Wi-Fi is multi-access coordination. So what is this multi-access coordination means? When there are multiple access points and few access points are connected, that means an access point connected to few stations, another access point connected to another few stations, like the diagram shown here. So if there is a setup like this, if this station is very near and if this station is very far, and if both of them want to communicate, because these are entirely two different networks, right? So this device can directly communicate to this access point to the other. Because what this access point do is they will be triggering some behaviors that enables different communications between two different services. An access point can communicate to the other access point. A device can communicate to the other device across multiple access points just based on the signal quality. This is one important feature that will be experienced hardly in one. Okay, so this is what the complete session is about. So mainly what I have discussed is have given some basic mechanism related to the Wi-Fi and two important features that will be coming in the Wi-Fi. One is MLO, other is multi-access file. So with this, let me stop here. The next session, the next half, I will be just briefly explaining some MATLAB codes and related things. So thank you. So we'll take a short break.